Hello friends. Hello friends. Today we are moving to the fifth chapter, that is control statements. So what are control statements? Control statements, those are controls execution of particular block of code. Programming language uses control statements to cause the flow of execution to advance and branch based on changes to the state of program. So that particular control statement will control the flow of execution in your program. There are three types of categories: selection statement, iteration statements, and jump statements. Selection statements allow your program to choose different paths of execution based on outcome of expression on the state of variable. For example, if that particular condition is true, then this will be executed, otherwise that will be executed. Then iteration statement enable program execution to repeat one or more statements, like for loop. Same block of code will be executed again and again for that specified number of times. That is iteration statements from loops. Then jump statements allow your program to execute in non-linear fashion. So if you are at line number, for example, 5, and you are going to line number 10 by using particular jump statement. So jump statement can be written and go to and like that. First of all, we will see selection statements. Two selection statements, if and switch. The if statement is Java's conditional branch statement. So that if that particular condition is true, this will be executed. It can be used to route the program execution through two different paths, like if condition, else condition. Okay, so if condition, else if condition, or else, like this. So if condition, that particular condition is true, statement 1 will be executed, otherwise statement 2 will be executed. So this will select which type of which block will be executed. That's why it is called as selection statement. Each statement may be a single statement or a compound statement enclosed in curly braces, that is block. So the block of code can be written in an opening and closing curly braces, or single statement can be directly written in a single line immediately after the if or else line. For example, if integer b, if a is less than b, I assign a is equal to 0. For this a is equal to 0, it is a single line. For that purpose, I am not using it as a block of code. So I am not specifying here opening and closing curly braces. But for more than one number of line of code, you have to specify opening and closing curly brace, which is compulsory in Java. Or else b is equal to 0. Most often the expression used to control the if it will involve relational operators. Relational operators we have already seen in the previous PPT, previous video. In that I have told you that there are some relational operators like greater than, less than, greater than equal to, less than equal to, equal to, and is not equal to. These type of relational operators will be used to control the if statement. This will result some boolean value. It can be true, it can be false. So depending upon the result, the compiler will decide whether I have to go inside the block, otherwise not. But if you can control the if using single boolean variable also. So you can specify single boolean variable which contains true or false, not 0 or 1 like C and C++ that we have already seen. So for example, boolean data available. If data is available, that is if data available value is true, process the data, else wait for more data. Okay, if data is not available, I will wait for more data to come in. only one statement is allowed directly after if or the else. So if you are having only one statement, then block of code opening and closing curly brace is omitted. But if you are having more than one statement, then you must write opening and closing curly brace to have that particular code. Some programmers include braces even if there is only one statement, just not to forget the brace in future if they want to add one or more statement, which avoids errors in future. For example, if you are writing any condition and for that particular condition only one statement needs to be executed, but in future if you will require that more than one statement will have to be executed, then you will have to write opening and closing curly braces. For that purpose, some programmers always write opening and closing curly braces irrespective of there is one statement or there are block of statements. So they will not forget in future and future errors will be removed in advance. Then nested ifs. The nested if is like if inside if. Nested if is an if statement that is the target of another if or else statement. So in that one if you can have another if else, or in one else you can have another if else. When you nest if, an else statement always refers to the nearest if. So whatever you are writing inside if, so inside if else will always refer to the nearest if that is available. So directly after the completion of if block, it can be single line, it can be multiple lines, closing curly braces. It should be immediately after else should be there, should be present. So if you are specifying any else statement, it will be very nearest to the nearest if statement. That is within the same block as an else and that is not already associated with else. So if you are specifying a new else and it is written in the same block where you have written the if block, and that if that else is not associated with any other, then it will be directly associated with that particular nearest if. Example, if I is equal to 10, if j less than 20, a is equal to b. Then if k is greater than 100, c is equal to d. This if is associated with this else. So the inside else a is equal to c is associated with its nearest if. Nearest if is what? If k is greater than 100. And this outer else is associated with the outer if. So this way you have to take care while writing the if else ladder or nested ifs. Then if else ladder we will see in detail. A common programming construct that is based upon the sequence of nested if, the if else ladder. If, else if, and then else. So if you have to check multiple condition for that particular variable, so you have to specify if else ladder. If condition, then statement, else if this condition is satisfied, calculate or run this statement, otherwise this statement, otherwise in the last else will be your default else this will execute the last statement. The if statements are always executed from top to down. As soon as one of the conditions controlling if is true, the statement associated with that if is executed immediately and the rest of the ladder is bypassed. So for example, if this condition is true, this statement 1 will be executed and whatever written after this will be bypassed. If for example this else if condition is true for your particular variable, this statement will be executed and remaining all will be bypassed. So as soon as one of the condition is met true, all other will be automatically bypassed. The final else is default condition. If all other condition test fail, then the last else statement will be performed. So irrespective of whatever conditions are written there, if those are failed, this last else is the default else and whatever you are writing inside this else will be executed, and that's why it is called as default else statement. If there is no final else and all other conditions are false, then no action will take place. So if you are not providing this default else and your variable or your condition is not satisfied over here, so no action will be performed at all. The next if else ladder example is there. For example, int month is equal to 4. Month is what? April. Spring season. So what is the condition? If month is equal to 12 or month is equal to 1 or month is equal to 2, season will be winter. If month is equal to 3, month is equal to 4, month is equal to 5, season is spring. If month number is 6, month number is 7, month number is 8, season is summer. And lastly, if month is equal to 9, month is equal to 10, month is equal to 11, season is autumn. Else season is equal to bogus month. So this is if else ladder. If this condition, season will be initialized to winter. If this condition, season will be initialized to spring. If this condition, season will be initialized to summer. If this condition is true, season will be initialized to autumn. Otherwise, by default, season will be initialized to bogus month. So April is in the season. So what is the output? April is in the spring, because month number of 4 is given, and which is for April. So 4 is allowed here. 4 is present here in this block. Month is equal to 3, or month is equal to 4, month is equal to 5. So here month 4 is present, so season will be initialized spring. Then next is switch statement. So what is switch statement? The switch statement is Java's multi-way branch statement. It provides an easy way to dispatch execution to different parts of your code based on the value of expression. So in switch block, expression will be evaluated first, and depending upon the value that is generated by execution of that expression, will decide at which case it will go and at which case the expression block of code will be executed. So here switch expression is the syntax inside case value 1 statement sequence break. Here you have to write understand it very clearly. Whatever you will write after this colon, it should be inside opening and closing curly braces. It is a good practice. For single line it is allowed, like in if else. If you can write without opening and closing curly brace, but still it is a good practice. If you forget in between, all blocks of code will be added together. So opening and closing curly brace after this colon is compulsory. You have to remember this. After that you have to write down break. Okay, so for why break? If you will not write here break, all cases will be combined and all statements will be executed one after another. For example, if your expression evaluates through 2, so after 2, if you are not writing break, whatever will be written until the default case is there, whatever is written, it will be executed. So break is compulsory, and also opening and closing curly braces are compulsory. Then case value and statement sequence break, and this is the default case. So it is a good practice you provide a default case, because if none of the condition is met, none of the case value is evaluated, the default case will be always executed. The expression must be of type byte, short, int or char. So whatever expression you will write inside this switch expression must be of type either byte, short, int or char. Each of the values specified in the case statements must be of type compatible with the expression. So whatever expression you are evaluating and whatever case value you are providing, they should be data type compatible with each other. Each case value must be a unique literal, that is, it must be a constant, not a variable. Whatever case value you are giving, it should be a unique constant value. it must be a constant, not a variable. So constant is what its value will not change throughout the program, and variable is what its value may change depending upon the evaluation of expression. So it must be a unique, constant, literal. So now how it works, the value of expression is compared with each of the literal present in the values in the case statements. If a match is found, the code sequence following that case statement is executed. Otherwise, default one is executed. If none of the constants matches the value of expression, then the default statement is executed. But the default statement is optional. You can specify, you cannot specify, but it is a good practice you specify the default statement always. If no case matches and no default is present, no further action is taken, like we have already seen in if-else ladder. So in if-else ladder, if the by default else is not present, so no action will take place. Like this, also like this. If in switch, if you are not providing a default statement, no further action is taken. The break statement is used inside the switch to terminate the statement sequence. So whatever you are writing for that particular case, break will break the execution at that place. So for example, if case 1 is evaluated, expression 1 is evaluating to value that is matching the case 1 value, after completion of all the block of code that is written in case 1, break will break the execution at that place and it will come out of switch case ladder. When break statement is encountered, execution branches to the first line of code that follows the entire switch statement. That is, switch case is stopped in between, and after switch, whatever is the first line of code present after switch case, the execution execution will begin with that point. This has the effect of jumping out of switch. So break statement is very much important. Now nested switch statement. One switch can have another switch. Okay. So you can use a switch as a part of the statement sequence of an outer switch. This is called as nested switch. So one switch as a part of statement sequence of another outer switch. Since this switch statement defines its own block, no conflicts arise between case constants in the inner switch and those in outer switch. So each switch statement defines its own block of code. So you can there cannot be a conflict between case constant of inner switch and case constants of outer switch. For example, switch count case 1, switch target case 0, target is 0, and case 1 target is 1, and break case 2. So here for this target there is 0 and 1, two values are present, and here case 1 for outer switch, case 2 for outer switch. So no conflicts arise between this case 1 and this case 1 because this is the inner switch. This is the inner switch and this is the outer switch. So no conflict will arise. More about switch statement. The switch differs from if is that switch can only test for equality. No other condition can be checked at the switch case ladder. Whereas if can evaluate any type of Boolean expression. No two case constants in the same switch can have identical values. So same switch cannot have no two case constant in a same switch. The same switch cannot have the two values, those are identical, those are similar, because everything will be unique, literal, present inside the switch value. Then, of course, a switch statement enclosed by outer switch can have case constant in common. For example, inner switch and outer switch can have case values, those can be same. But a same switch ladder cannot have two values, those are similar. A switch statement is usually more efficient than a set of nested ifs. So switch statement is more efficient than a nested if. Why? Because it is very easy to understand. If you want to test only equality, then it is very simple to write down, simple to understand, simple to manage. Okay. So if you have to check only equality, no other Boolean expression you want to evaluate, then it is better you write switch case other than if else. When Java compiler compiles a switch statement, the Java compiler will inspect each of these case constant and create a jump table that it will use for selecting the path of execution depending upon the value of that expression. So jump table will be created by Java compiler, and that jump table will tell the Java compiler after this evaluation is true or false where I have to go and which block of code I have to execute. Therefore, for large group of values, switch statement will run much faster than if else. So, because of this jump table which is created by Java compiler, so it will run faster than if else. So, it is recommended always. So, if there is only equality check is present, then you should always use switch case other than if else, because it is very much faster. Iteration statements. Now we have seen the selection statements. Now we will see iteration statements. There are for while and do while. So we will see one by one: for loop, while loop, and do while loop, who creates loops. Loop repeatedly executes the same set of instructions until termination condition is met. Unless and until condition is false, the loop will execute repeatedly. While loop. The while loop repeats the statement of block while its controlling expression is true. While condition is true, statement will be executed. As simple as that. General form: while condition, then body of the loop. The condition can be any Boolean expression. Until true, body of loop will be executed. So unless and until that Boolean expression evaluates to true, the body of loop will always be executed. When false, the control passes to the next line of code immediately. Example of while. Here, number n is equal to 10 I have initialized, while n is greater than 0. Unless and until condition is true, n is greater than 0, 10 is greater than 0, yes, 10 is greater than 0. Then tick will be writing 10. Then n will be decremented by 1. So 10 now becomes what? 9. After this, again loop comes here. Now 9 is greater than 0. Yes, 9 is greater than 0. Then tick will write what? 9. Again 9 will be decremented and n will become 8. So 8 is greater than 0. Yes, 8 is greater than 0. Okay. So this way it will come till there is n is equal to 1. After 1, n will be 1 minus minus will be 0. So 0 is greater than 0, false. After this condition is false, it will come out of the while loop. So this is the output. Tick 10 to tick 1. The body of while or any other Java loops can be empty. Body can be empty because a null statement is syntactically valid in Java. The one that consists of only semicolon. Okay. For example, if you want to create a gap for some time, to create a gap, a threading and wait, all these things will come afterwards. But while you are coding, in between, if you want to create a gap, for example of 10 seconds, 15 seconds, what you will do? For 100 times you will create one variable of 100 and then you will minimize it to 0. Unless and until that 100 becomes 0, you will do nothing. So you have to pause, you have to take pause of execution in between. So for that, to create this type of pause, you can always give a null statement that is containing only a semicolon, which is always allowed in Java. So this is the example. Class nobody, integer I is equal to 100, j is equal to 200. Find midpoint between I and j. while plus plus I is less than minus minus j. So what is plus plus I? Plus plus I is what? First of all, 100 will be incremented and then value will be assigned to I. So 101 is less than 199. 101 is less than 199. Yes, condition is true. So you will do nothing. Here only semicolon is given. Then 102 is less than 198. Yes. 103 is less than 197. Yes. 104 is less than 196. Yes. This way, unless and until this value is less than this value 149 and 149. Here 149 is not less than 149. So how firstly increment is done and then assign. So 149 plus 1 150. So midpoint 150 will be printed over here. Then do while loop. When condition is false, body of while will not be executed at all. Condition is false. You will not go inside at any cost. However, sometimes there is a condition we need to execute statement at least one irrespective of condition is true or false. Whether my condition is true or false, I need my statement to be printed. I need my statement to be executed at least once. In that case, I will use do while. Do body of loop while condition. Each iteration of do while loop first executes the body of loop and then evaluates the conditional expression. So, irrespective of while condition, whatever it is written here, it does not uh, require to check it. It will always execute this body of loop at least once. If this expression is true, the loop will repeat, else loop terminates. First time body of loop will execute it. After this, if condition is true, loop will repeat this body of loop execution again, otherwise it will come out of the do while loop. Do while is mostly used in menus. Okay, so while entering menus, enter your choice like this. While user need to enter the choice for choice, it should be displayed. Choices should be displayed to the user at least once. For that purpose, do while will always show you first time menu, irrespective of whatever input it is giving from the keyboard. Then for loop. What is the syntax of for loop? For initialization, condition and iteration. How it works? When the loop first starts, the initialization portion of loop is executed only once. Initialization is done only once. Condition is evaluated, that is the between part, this part condition. This must be a Boolean expression. If expression is true, then the body of loop is executed. If it is false, the loop terminates. And then after body of loop is executed, after initialization and condition, lastly iteration will take place. At each pass, increment or decrement iteration occurs. Class for tick public static void main. Here number n is created for n is equal to 10, n greater than 10, n minus minus. Here n is initialized to 10. So n greater than 10 will not be true. After loop ends, I vanishes. Okay. So n is 10 and n greater than 10 is not true. For that purpose, it will not go inside. Loop control variables can be declared inside the initialization portion of for loop. So control variables can be declared inside here, integer n is equal to 10, or it can be declared here, integer n is equal to 10. So it depends upon you. Variable I is declared here, and then after loop is end, n vanishes. So n scope and lifetime is limited to this for loop only. After for loop is ending, the output is n is vanished. Okay. Then comma. When you want to include more than one statement in initialization and iteration, use comma. Condition cannot be multiple. Condition can be only one. But while initialization, you can give multiple initialization of multiple variables and increment and decrement of multiple variables. But condition will be always one. For example, a is equal to 1, b is equal to 4, a less than b, that is 1 less than 4, a plus plus, b minus minus. So unless and until a is less than b, this loop will iterate. Expression in for loop does not need to test loop control variable against some target value. For example, the expression in for loop a less than b does not need to test loop control variable against some target value. So every time it is not compulsory to test loop control variable. Here boolean done is equal to false. For I is equal to 1, not done I plus plus. If interrupted, done is equal to true. Okay. So not done will be what? True. Done is false, not done is true. For integer I is equal to 1, one time it will do, one time it will check, done is true, then it will go inside, and if interrupted in between, done will be again made to true. This statement is allowed. You can create infinite loop by leaving all three parts empty. For this part is empty, this part is empty, and this part is also empty. Like all other loops, for loops can be nested. You can have one for loop inside another for loop. That is, one loop may be inside another. Then lastly, we will see jump statements. Jump statements are break, continue, and return. One more structured jump statements are contained in exception handling. It uses try, catch, throw, throws, and finally. All these are jump statements. But for now, we will see what? Only break, continue, and return. Break. It is used to terminate statement sequence in switch. It can be used to exit a loop. So, first use of break is terminate statement sequence in switch. We have already seen. Then it can be used to exit a loop. To come out of loop, you can always use break. It can be used as form of go to. When used in loop, it terminates the loop, bypassing the subsequent statement that those are remaining in loop. And program control resumes at the next statement following the loop. When used inside a state of nested loop, the break statement will only break out of the innermost loop. It will not come out of the outer loop. Using break as a form of goto, these are the very important points you need to remember. It can be used as civilized form of goto because Java does not provide a goto statement. Why? Because it provides a way to branch an arbitrary and unstructured manner. While you are using goto, one statement can go to another, and it is providing label, and another again it is going to the next go to label. So control flow from one statement to another statement is not very much easy. It makes it arbitrary and unstructured manner. This usually makes go-to-return code hard to understand for new users or a new programmer which is handling the code, and hard to maintain. It also prohibits certain compiler optimizations. Sometimes it is necessary to come out of deeply nested set of loops. So to come out of a deeply nested set of loop, we will require something to come out of. So for that purpose, we use break label. Control is transferred from the named block of code. So you better specify a label to that block of code from which you will require in future to come out of, and after that if that particular condition is met, you will come out of that particular label, and your flow of execution will be easy. So unless instead of using go to, Java uses break label. Then continue. Sometimes it is useful to force an early iteration of loop. So only early part of loop I need to repeat, and whatever written afterwards till the end of loop I don't need to repeat. For that purpose I use continue. Continue is another form of statement, iteration jump statement. That is, you might want to continue running the loop but stop processing the remainder of code and in its body for this particular iteration. For that purpose you will use continue label. This is the example. For example, I is equal to 0, I less than 10, I plus plus, system.out.print I, and then space. If I module 2 is equal to 0, I need to continue. So not every time I module 2 will be 0. If I module 0 module 2 is equal to 0, it will be true, but 1 module 2 it will not be equal to 0. Then 2 module 2 will be 0. 3 module 2 will not be equal to 0. So for every time when I module 2 is equal to 0, I will need to continue, and then for that purpose I will use this continue. After continue, this statement will not be executed. It will continue from the start of the for loop. Output of this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Continue also specify a label to describe which enclosing loop to continue. With continue, you can also specify label like a break label to describe which enclosing loop you want to continue. Syntax is continue label. And last is return. The return is used to explicitly return from a method. It causes a control to transfer back to the caller of the method. While when you are using method call, the return is present there, but it is not shown every time. After completion of that particular method, the program will always return to the main method. But when you want to explicitly return from a method with particular value, then you will specify a return. It causes the program control to transfer back to the caller of the method with particular value. You can in between write only return semicolon, or you can return with particular value, or with when you are using that return, it will program control will be transferred automatically back to the caller of the method. So this way we have completed control statements. In the next video we will see control statement with practical part, and we will understand if else, while, for, and all the return statement and its usage. So meet you in the next session. Thank you so much.